Alright, so let's talk about templates. Templates allow us to create like one template and then use it over and over and over again. So we're going to create like, one web page, and then we could customize that web page and fill in things like, hey, in this position we want to insert the user's name, or in this position we want to insert this piece of data, or loop over this data and have that display. So that's the idea behind templates. I kind of think of them like form letters, right? So a form letter would be a template that would fill in personalized information from a database. So if you had a form letter, and we could just Google that form letter, and let's find a form letter here. To whom it may concern template. See, right? They even have one called templates. And let's see if it has fields. I'm just looking to see. Here we go. Right? So here's one that says name of recipient, title, company address, city, state, zip, name of recipient. And so these fields here would get filled in as you went through a database, right? Like for each record, it would fill in the appropriate information and then print that form letter. And so that form letter is going to be the same pretty much, right? Like all the text will be the same, but it'll be like who it's addressed to and everything like that will change each time. Well, that's a template, and same thing with web pages. So we're going to look first at like text templates, and if you look at the documentation, text template, there we go. We have package template, which is import text template, but then we also have package HTML template, right, which builds upon the text template. And the only difference is the HTML template will create templates that are safe for HTML output, meaning if somebody tries to do like cross-site scripting or inject some code into your template, like some JavaScript or something like that, it will escape that characters, and we're going to see that here in a second. But we start out with package text template. Let me just make this big screen so it looks a little bit clearer to you. And we're waiting for big screen. It is loading. There we go. So package template implements data-driven templates for generating textual output. To generate HTML output, see package HTML template, which has the same interface as this package, but automatically secures HTML output against certain attacks. Templates are executed by applying them to data structure. Annotations in the template refer to elements of the data structure, typically a field of a struct or a key in a map, to control execution and derive values to be displayed. Execution of the template walks the structure and sets the cursor, represented by a period, and called dot, to the value at the current location in the structure as execution proceeds. The input text for a template is UTF-8 encoded text in any format. Actions, data evaluations, or control structures are delimited by those, what do they call those, curly braces. All text outside actions is copied to the output unchanged. Except for raw strings, actions may not span new lines, although comments can. And then here's an example, right? So we have a struct and with two fields, and then we create an instance of that struct, right? So here we have inventory, and we're giving it wool as the material and count as 17. And so we're creating a variable of type inventory, and we're giving it this value right here, right? So sweaters is a variable. Hold on one second. My dog was barking. Sorry about that. I'm out front in front of my house at 1 a.m. in the morning trying to get my work done. All right, so just trying to get the, what do you call it, just the diction correct, because Golang, Go has a language all its own, a language that describes the language. And so here we have a variable sweaters of type inventory with a value of that wool and 17. So that's how you'd say that. So then on the next line we're saying create a new template, and we're just calling it test, and then we're going to parse this string into the template, right? And then once we have our template, we'll execute it. We're going to send it to standard out, and we're going to pass in this data, sweaters, right there. And so when we do all that, it would print out 17 items are made of wool. 17 items are made of wool. So count came from here. No, sorry, count came from here, 17, and wool came from there. And you can see this notation with the curly braces, and then the dot, and then the field name for a struct. And so that's the basic idea of templates. So let's take a look at just starting to build one up from the beginning and sort of breaking it out a little bit more. Here we have template parse files, and so we're parsing template go HTML, and here's that file template go HTML. So it's parsing this file and putting it into a variable, and that's going to, when you do template parse files, it'll give you a pointer to a template. And so you can see that over here. Well, I already have it up. Godoc right there, and template parse files. Template parse files returns a pointer to a template, right? Parse files returns a pointer to a template. That's pretty cool. New would return a pointer to a template too. So here we have template parse files, and it gives me a pointer to a template. And then with a pointer to a template, right? When I have a pointer to a template, so template parse files gives me this pointer to a template. And then with a pointer to a template, I have all these different methods I could choose from. And so one of the methods here is just execute. And that will take a writer. So where do we want to write, our execution back to? And meaning like, hey, this template, when it's executed, where do we want the output to go? Like to your screen or to the web or where? And then it takes data, right? And that's of any type. So we could pass that in, and it returns an error. So we have our pointer to a template, and then we could run the execute method off of that. And we're saying print this to standard out and don't pass in any data, no data. And so basically it took this file, parsed it, turned it into a template, and then executed that without giving it data and wrote it to standard out. And so it printed this right to my terminal. So that's the basics right there of creating a template using parse file. And you can look at the different actions you could use with a template here. And we're going to see this more in just a second. But here I didn't have any actions whatsoever. But in this file, I do have some actions. Right, so again, I'm parsing my template, go HTML, parse that template, get my pointer to the template, run the execute method off of it, to standard outs where I want to write it. I'm not passing in any data. But over here, I've put the curly braces, and I've put in a literal value, numeric literal, and that is 5, right? And so it just prints out 5. So it evaluates that, but just says, hey, this is a literal value, and just prints it out. There's no other, sort of evaluation necessary. It's not an expression. Well, actually, it is an expression, but it's just a literal value. That's it. Okay, so here, same thing, template go HTML, and I'm parsing that, right? And this time I'm passing in data. I'm passing in 10, and here in the template, I'm putting just a dot. And so that dot right there says take whatever data is passed in and print it right there. So when this gets executed and written to standard out, this is what gets written to standard out. So we're starting to see this thing where we could pass in data, and it'll take that template and it'll fill in any fields, right? Right there with the data, and so you can see that. So you can think of the dot like the dot in Unix. Just like in Unix, the dot means the current directory. Here, the dot means the current data. The dot is, you can also think of the dot kind of like as the pipeline. And so that brings us back to these actions here, which I was talking about just a second ago. And so here, we have all these different actions. Here are curly braces, right? And we have all these different actions we could take. We could do if logic. We could do if else. We could do a range, right, where we loop over data. We could do a range with an else clause. We could also do templates and do things with templates here. But this stuff, this pipeline here would be the dot. So the pipeline is kind of like what's the current data. So what exactly does that mean, right? Like if I had a slice of structs, and so just picture that for a second. Like a struct is something like this right here, right, where I have material and count, and then here I've created a variable with a value, right, of that type. And so if I had like 10 of those, I had sweaters, shoes, socks, I might put those all into a slice. Then I could pass the slice into my template, and I could range over my slice, right? So right here I could range over my slice, and each time I range over my slice, each value would be a struct, right? So anyhow, the dot is kind of like the current value in the pipeline, and the first dot when I ranged would be the slice, and then inside here I could reference like the dot with a field name. So you'll see that in a second, but but the dot, you can kind of think of the pipeline as the dot. That confused me at first when I started learning Go. I was like, what's a pipeline? Because I don't have a strong Unix background. So anyhow, here's another example, right, of parsing this into a template. And so there's the text I'm parsing in, and here's where I'm going to put, some data that I'll pass in. There's the field. And then I'm going to execute that. I'm going to pass in this expression, and it gets evaluated and prints out, 5 times 5 is 25, so prints that out. And here I'm passing in a slice of ints. And so now we're starting to see range, right? So this is what I was just sort of trying to describe. Here the dot is my slice of ints, right? So I'm going to range over all of this data right here. That's what the dot represents there. And then right here, the dot is, okay, now that I'm ranging over this, each loop, right, this is going to be the data, this will be the data, this will be the data. So at first, the dot is all of this, right? It's my current piece of data. But then as I range over that, the dot becomes this. That's my current piece of data. The next time I loop, that's my current piece of data. So the dot sort of represents the current piece of data. Just like in Unix, the dot means the current directory, right? And the pipeline is like this pipeline where, okay, this data flows in, and then this data is flowing in, and what's my current piece of data? That's kind of how you could think about it. And so here we can see the output is 1, 2, 3, 4, 5. So again, just to break it out how it's happening, we have template parse files. And we're parsing this, and we get a pointer to a template, which means we could run the execute method. We're going to write to standard out, and then we have this data which we're passing in, and we're using this action right here. Right here are the different actions we could use. We are using the range pipeline end right there, range pipeline end, and then in between we're looping over that. And we're saying, okay, each piece of data every time you loop, print that out, and that's where that gets printed out. So that's kind of how you read all that. So this templating is very much like templating you'd find with handlebars.js or with Mustache, but I think it's better because it's baked right into the language. All right, so I just thought I'd point that out, right? And those templating packages also use curly braces, which is why they got their names handlebars or mustache, right? It looks kind of like a mustache. So here's another example where we're using a range else. I'm passing in an empty slice of ints, right, with nothing in them, and then here I get no items. So that is a slice of int with nothing in the list. Yeah, so there we go. And no items prints out, so you can see the conditional logic working there. All right, next thing here, I create a struct. Page struct with the title and body. I'm going to parse this file, template parse files, template go HTML, and I got my title field right here. I get my pointer to the template. I could run this method, write to standard out, and then I'm creating, what would you call that? This is type page, right? So struct literal right here, right? And so it's not assigned to any variable name. Maybe you'd call it an anonymous struct literal because it's just like I'm creating one instance, and that's not necessarily the best word to use with Go programming. I'm creating anonymous struct literal. That's the best way to describe it. Anonymous struct literal, right? I didn't assign it to a variable name, but it's of type page, and it has only one field, or the title field is set to my title 2, so the title field is initialized to that, and then body is going to be set to its 0 value, which will be an empty string since I don't specify it. And so when I print this out, I call the dot title, right? I'm calling dot title, so the data I pass in is all of this struct, and dot title, I could access the field name that way. And so here is, what am I doing here? You could also pass in funcs, right? You could have a function run in your templates. And so to do that, you get your pointer to a template, and then one of the methods that runs off of templates is funcs right here. And so funcs takes a func map and returns a pointer to a template, right? And so that's kind of cool because I get my pointer to a template, and I could run this, and it adds like a func map, and then gives me a pointer to a template back, so it just like reassigns. And you can see here, I get my pointer to a template, and I run this function off of it, and it just gives me a new pointer to a template, so I replace what was here with this value. So it just added functionality to my template, right? And so template funcs takes a func map. And so if we look at what a func map is, right here, template funcs, right? A func map is a type, and it's type func map, and the type of func map, the underlying type, is this, right? It's a map with a key of string and a value of any interface, right? So this means an empty interface, so this means it takes any type right here. And so we could see that set up right here. So here we have template func, so I run this method, and template the package func map, right? Because template funcs, right, takes a func map. And so here we have template funcs, and then I'm passing in the argument right there, and it takes a func map. So template is the package, and a func map is the type, right? And so this type is going to have what? Keys and values. And so here's the key, my custom func, and that's a string, and we saw that here, right? The key is a string, and then I could pass in any value right there. Empty interface means any value, so the value is a function. And so here's my function, and my function takes nothing and it returns a string, and the string it returns is this should work, right? So I've added this function to my template, and now I could parse my files. I'm going to add in this template right here, right, into that, and then I'm going to execute that to standard out and pass in this data. So this data here is a struct literal, anonymous struct literal, and it's my title. And so when I run this, I get here my title for my title, and then for my custom func, this should work. So I think this code would actually be a little bit more clear, because it's kind of, this confused me right here when I first was learning that, because it's like new and that name, and then I parse it in, what's going on there. And so I think I'm going to rearrange this code and go into my templates, and I'm looking at text templates, and we're at the function part, so I think this is the one right here. But basically right here all this is doing is giving me a new template, and so let's run this and just see that working. And so I need to clear that out, and let's see, and then change directories and go into 01. Miss Paget girl, please quit barking. And then once I'm in 01, I need to go to 09, go run main, and that all runs, right? This should work. That just printed out. But here, instead of doing it this way, right, I could come over here and I could see that there's a couple other ways I could do that, or one other way I could do that. Here we go. I could do right here and just do new and get a pointer to template, and then I'll have access to all those methods. And so func new a name. Well, sorry, that's what I'm actually doing right there. Better yet, this is what I was thinking. Var temple is a pointer to a template, right? From package template, it is type template. So here you can see that I'm getting type template, and type template here is inside text template, right? So from package template, I have type template, and it's I want a pointer to that, because where is type template? Right here. If I have a pointer to type template, right, and there's type template, if I have a pointer to type template, then I'm going to be able to run all of these different functions. So I can then get rid of that line right there, and this should still run just fine if all goes accordingly. Live coding is always a bit of a gamble. Oh, that's so disappointing. Let's read what this is. Let me figure this out. Alright, so quite frankly, I don't know what is going on there, because over here I do the same thing, but I do it with parse glob, which we're going to see in a second, instead of parse files. And when I do it with parse files, which I'm running on the file on the left, I get this thing about invalid memory address or nil pointer dereference. And when I do it with parse glob, I get, and this is a 05, right? No big deal. So that totally works. So I'm not sure why it works over here and not over there, but you know, that's programming and something to reflect upon when I'm not so tired, and it'll probably be totally obvious at that point. So I'm just going to turn this file back to the way it was, just a bunch of Command Z undos and get rid of the template stuff. And there's me trying to figure it out in different iterations, and that's the way it was. And so now this should be working again. And that is 09. Yeah, cool, no problem. All right, so it's kind of interesting here when you do template new, you give it that name. I think that's a little bit weird. And then you also do parse files and you give it the name of the file you're parsing. And if I give this any name, what happens, right? So like maybe that name doesn't matter at all. And any name is incomplete or empty template, right? So I guess when I do template new, I have to give it the name of the template I'm going to be using. And then parse files is like go get that file of that name. So that's kind of funny. Let's look at the documentation, or we could just do it right here and see what that has to say. So template new gives us new name string, new allocates a new undefined template with the given name. It gives us a pointer to the template, all right. And then parse files, right, takes file names, string, an unlimited number of arguments of type string, and so parse files parses the named files and associates the resulting templates with T. If an error occurs, parsing stops and the return template is nil, otherwise it is T. There must be at least one file. Since the templates created by parse files are named by the base names of the argument files, T should usually have the name of one of the base names of the files. So T is the template, right? And T should usually have the name of one of the base names of the files. If it does not, depending on T's contents before calling parse files, T execute may fail. So that's kind of what it's telling us there, that T, right, when we get a new template here, because that's what T is right there, it's a pointer to a template. So when we get one of those, the name should have should usually have the same name as one of the base names of the files, and so that's what we're doing right here. Anyhow, that's just kind of interesting. And so moving on to the next examples. What do we have here? This is the one we left off with right there. And then here we're seeing how new gives us a pointer to template, and we have all those methods associated with it. And then I kind of look at that a little bit more closely, right? New gives us a pointer to a template. And then we could do funcs, right, which is attached, a method attached to a pointer to a template, and that returns a pointer to template, and it takes a func map. And then, whoops, wrong way. And a func map, right, is a type. So it's a type, right? Just like int is a type or string is a type. Func map is a type, and its underlying type is a map. And it's a map that's defined as having a key of a string and a value of an empty interface, which means it takes anything. So we kind of already went over this. And then once we have that func map, right, we pass in our function right here, and you can kind of see here I'm doing template funcs, and template funcs, right, takes a func map, and so here's the func map that's being passed in from package template type func map, and type func map is going to be a key, which is a string, and then an interface, right, anything, empty interface, and so I'm passing in a function, and so function's a type in Go too. And then finally we have parse files, and parse files is right, parsing this file right here, giving us a pointer to a template, and then we could execute it. And when we execute it, it says where do you want it to be written. The writer, IO writer, implements the writer interface, and what data are you passing in. So I'm passing in that empty, not empty, but I'm passing in the anonymous struct literal. There we go. All right, so here is using a function uppercase, right? Passing in a function uppercase, so it's doing a little bit more, and it's taking whatever data I give it here and turning it into uppercase. So it takes one argument, and you can see I passed in the data title, and it passed it in. Generally speaking, putting functions into your templates isn't something you probably want to do. You want to do all of your processing on your Go side, and then you know, before you render your templates, and then when you render your templates, just pass in the data, right? Because I could have passed in this data looking like that. So really needing to do this here is just kind of a little bit more convoluted and messy, and not necessarily the best separation of concerns. All right, so the next deal, oh dude, did I hit record? Yeah, all right, cool. Padgett, please stop. The next one is showing you here how when I'm using text template, if I pass in some tags, right, like JavaScript tags here, or HTML tags to run JavaScript, then I just get that passed right on through to my template. That's using text template. But when I switch to HTML templates, right, so now it's HTML templates, if I pass in the same thing, all of that gets escaped. So that won't run if I was to render that in a browser, right? And so that's how HTML templates make templates safe for the web. And they're exactly the same as text templates, but they just have added functionality, you know, to work on the web. So all the stuff when you're working with HTML templates, everything you learned about text templates works with HTML templates, and then HTML templates does a little bit more. And if you wanted to, you could sort of bypass all that. So here I made body, instead of having body be just type string, right there. Here I made body type template.html. So if you make it that type and you pass in, you know, your HTML tags, those will come straight through as, you know, HTML, and so they won't be escaped. So that's just a little workaround. So we've been working with parse files, right? Like right here I'm parsing files, and we've also been using just execute, right? So right here I'm using execute. So we've been working with parse files and execute. There's also parse glob and execute template. So let's see what the difference is between those. So parse files is going to take, you know, an unlimited number of file names, and then parse glob will take a string, and that string is going to be a pattern, and each of them return a pointer to a template and an error. And then execute and execute template. So basically with this one, I could pass in a bunch of individual names, right? Like this file, and then this file, and then this file, and this file, and it'll parse all those files. With this one, I could say, hey, just go look in this folder and parse everything you find in that folder that has like this extension. And so then it would do that. So two roads to the same place. And this way, I got to list each file name. This way, I just list the folder and say files with this extension, parse all those files. And then here I could execute, right? And so execute is going to just basically execute one, and then execute template will execute, and the one that it executes is just like the default main one, and we'll see that. And then here execute template, I could say, you know, I want to specifically execute this one template. So the best practice, I think, is to parse glob, keep all of your files, templates in a folder, and then use parse glob, and then you'll have access to each of those templates by name. And when you want to use one of the templates, you just give it its name. So let's see that in action. So here we go. Here we have parse files, so we're not doing parse glob, and we're parsing these two files. And so there are those two files in the directory structure. And the first time I'm just going to do template execute, in which case it gives me from TPL, right? Just ran this first one. And next time I'm going to do execute template TPL, and it gives me TPL again because that's what I asked for. So first time I did execute, this time I did execute template, and here I'm going to do execute template again, TPL2, and it gave me TPL2. This is from TPL2, right? So you can kind of see parse files. I got to list each of the files I want to parse, and then, you know, the difference between execute just gives me the first one. Execute template will give me whichever one I specify. And here you can see I use that var TPL template. Totally awesome. Don't know why it works here and not in another place. I'll have to go figure that one out. So here, instead of using parse files, I'm using parse glob, and I'm saying look in the templates folder, which I created right here, templates folder, and grab all the files, so any file, any name that has this extension, right? And so it grabbed all those files, and then again, the execute template works the same way. This gives me the default first file, temple. This one is temple, I specify it, and this one is temple2, right? I specify it with execute template. So that's the difference between parse files, parse glob, execute, and execute template. I think those are really good examples. A couple of exercises for you, right? Maybe you want to try these. Create an HTTP application that returns hello with your name using a template. And so the solution to that would be like this. You could pause the video if you want and sort of take a look at that. And then the next one is create an HTTP application that returns the currently selected URL. Use a variable in your template. And so that would be like this. And, you know, I'm passing in right here for the data, the request URI, right? And then I'm going to print that there. So it prints out whatever, you know, the path is beyond the domain. And then here, parse a CSV file, then using templates, send the results as HTML to a web browser. And so I'm going to start with data that looks like this, a CSV file, and I'm going to end up with something that prints out like that. Ooh, pretty cool challenge. and pretty dang easy, right? So first I just call this parse function, which I wrote in another file, and so we could see that right here. There's parse, and so parse has a method, right? The package parse, which I created, has a method parse, which takes in a file path. It opens that file path, defers the close, and then gives me a CSV new reader and passes in that file, and then reads it all, which returns all of my rows. And then I want to have some data structure, so I'm going to have, here I have type record struct, right? And so here I'm going to have a slice of record, right? So I'll keep all of them. And so I'm going to range over all my rows, and this right here, time.parse, turns the first row, the time, into that format. And then this one takes the second entry, so the first field in each row turns it into that time, and the second field in each row turns it into float 64. And so then take the date and open and set them in the struct and append that to my records, right, which is that slice, and then return records. So when I return records, I get records here, and then records gets passed in as data there, and I just parse my template right here, right, and then I execute my template and write it back out to the response writer, which takes an IO writer. The write implements the writer interface, and so that's going to write that back out as the response from the web server, and it's going to parse the data records. And so the template is right here. Sorry, I said parse the data records. It's going to pass in the data records and then build that into the template. And so here's my template, and right here I range over the data I pass in. And so each time it loops, it'll be a row or a record, and I could access the fields .date, .open. And so when I run all that, I get this, which is the date and the opening price. So that could be formatted better, obviously, but I didn't do that. Anyhow, pretty cool stuff, templates, and really awesome, really powerful. And, this is it, man. You're like at the gateway for building web apps. So congratulations to you if you're just figuring this out, just learning it, and you've made it this far. You're doing great.